My name is Jonathan Hicks, and today we're adding and subtracting fractions. Now, adding and subtracting fractions is probably the least favourite topic in fractions for a lot of people. I never really got it in the first place and always struggled with those adding and subtracting questions. Now, I'm going to show you two different methods for doing this, and I'll split it into two different videos. So this video is going to be the traditional method for adding and subtracting fractions, which I do actually prefer. It's a little bit more difficult to learn in the first place, but once you get your head around it, it tends to make the questions easier to do in practice. I'm also doing another video though on the grid method for adding and subtracting fractions, which is definitely easier to learn in the first place, and for that reason a lot of people do prefer it. But in practice, sometimes the numbers can get quite big and it can make the questions a little bit harder to do. So it's your choice, you can watch both videos and make a decision. I'm going to go over the concepts first in this video, and then I'll show you how the traditional method works. So if we start with some pizza, it's always a good place to start. I'll split it into quarters. So if we have 1/4 to start with, if I shade in one of those, so 1/4, and then we add 2/4 to it, well, here's another 2/4. I can just shade those in. And we'd write that down, adding 2/4 like that. Well, if you've got 1/4 and you add 2/4, altogether you've got 3/4. I mean, hopefully you can see that from the picture. But this does illustrate a common misconception when it comes to adding and subtracting fractions. Because when you multiply fractions, you multiply the tops and you multiply the bottoms, a lot of people think when you're adding fractions that you add the tops and add the bottoms. But hopefully you can see here that that's not happening. We do add the tops, 1 plus 2 gives you 3, but we're not adding the bottoms. Yeah, it's not 4 plus 4 to give you 8. That's not going to work. If you had 3/8 here, if I do another pizza, and split it into 8ths this time, and then colour in 3 of those, you can see that is nowhere near that. They're different, very different. So you can't just add the tops and add the bottoms, it doesn't work. Effectively, if you remember, the number on the bottom of a fraction tells you the kind of slice you're dealing with. In this case, we're working in quarters. You can't suddenly change it and end up with 8ths at the end. If you're starting in quarters, you need to finish up working in quarters. If you've got 1/4 plus 2/4, you've got 3/4. You can't end up with 3 of anything else. And it doesn't really matter what the number on the bottom is, as long as it's the same. If you've got 1 of these things plus 2 of them, then you're going to end up with 3 of them. So you add the tops, or when you're subtracting, you subtract the tops, but the number on the bottom never changes. Let me show you quickly with subtraction. If we start off with 3/8, like this one, and we take away 1/8, I can probably just rub out this little bit here. That's 1/8 gone. Well, 3/8 minus the 1/8 is just going to leave you with 2/8. And it's as easy as that. The number on the bottom never changes. You just subtract the tops. 3 of these things minus 1 of these things leave you with 2 of these things. So the concepts that underlie adding and subtracting fractions are just that. And honestly, the concepts don't get any harder at all. We can make the numbers more difficult, which we'll get to in a second, but essentially the number on the bottom tells you the kind of fraction you're dealing with. You want to leave that the same, and then you just add or subtract the numbers on the top and the bottom. Oh, on the top rather. Add or subtract the numbers on the top. Alright, let me give you another example. As you can probably see, if the numbers on the top, if the numbers on the bottom are different, it gets a little bit harder. So let's have, yeah, we'll do it here. 1/2 plus 1/4. So now my numbers on the bottom are different. I've got different kind of slices. I've got halves and I've got quarters. So if I draw a picture, that would be like having 1/2 here and then adding onto it 1/4. So I've got this and I'm adding 1/4 onto it. Now again, you can probably see that that's going to be 3/4. But in terms of how you deal with it with the numbers, what you want is to have the numbers on the bottom the same. As long as you can make the numbers on the bottom the same, you can just add them because it's the same kind of slice. And again, 1/2 you can change into quarters by saying that 1/2 is just 2/4 plus the 1/4 gives you 3/4. So on the picture, the 1/2 has become 2/4. Effectively, I've just drawn a line across it like that. And then this is the same kind of thing we had before. and it's very easy to do. So adding and subtracting fractions where the number on the bottom is the same is really easy to do. If it's not the same, all you need to do is convert them so the fractions have got the same number on the bottom. The tricky part about adding and subtracting fractions is how you convert the fractions to make the number on the bottom the same. Alright, let's try a slightly harder one. And I'm not going to draw a picture this time, so this will be more of a challenge. If we have a third plus, let's have 2/5. Let me rub that out. A third plus 2/5. So, it'd be nice if we could just do like we did with a half and change the thirds into fifths, but thirds, you're not going to be able to rewrite thirds as fifths. With the half and the quarter, quarters obviously went into half. You could fit 2 quarters into a half. You can't fit fifths into thirds though, so what do we do? Well, the short answer is here that the number on the bottom that you want to change these into, the kind of slice you want to go for, should be what's called the lowest common denominator. You may remember that from school. Sometimes it's called the lowest common multiple, but whatever you call it, essentially it's the smallest number that's in both these times tables. Let me show you what I mean. If I write out my 3 times table, 1 3 is 3, 2 3s are 6, 3 3s are 9, etc. We'll just keep going. I'm going to go for quite a while here just to make a point. That'll do. And then the 5 times table, 1 5 is 5, 2 5s are 10, etc. Okay, so you're looking for numbers that are in both times tables. So 30 is in both times tables, but so is 15. And when you're doing this, you want the smallest number that's in both times tables. I'll explain why a little bit later. So let's work down with this one. So I want to rewrite a third as something over 15. In fact, we're going to rewrite both of these fractions so you've got 15ths on the bottom instead of thirds and fifths. So that's going to be 1 over 3 is going to be something over 15. We'll worry about what that something is in a moment. And again, the 2/5 is going to be changed into something over 15. Now, if you remember from your cancelling fractions, if you're not sure about cancelling fractions, go and watch the cancelling fractions video. When you cancel fractions, you took 2 numbers and you tried to make them smaller. In this, we actually want to make the numbers bigger, but the principle is exactly the same. Whatever you times the bottom by here, you must times the top by the same thing. And then it's still the same fraction and we're all good. So in this case, 3 times 5 would give me 15. So I must times the top by 5 as well. You're timesing both the top and the bottom by the same number, in this case 5. So 3 5s make 15, and 1 times 5 would just give me 5. Here, I'm having to times the bottom, the 5, by 3 in order to get 15. So I must times the top by 3 as well. So 5 times 3 is 15, 2 times 3 is 6. So I've times the top and the bottom of this by 3, so 2/5 is the same as 6/15. And the point here is that this third is exactly the same as 5/15. You can probably see that 5 is a third of 15. This 2/5 here is exactly the same fraction as 6/15. I haven't changed the fractions. I haven't changed the question. This is still exactly the same thing. But the point here is that the numbers on the bottom are the same. So now I can add them. I'm working in 15ths. I've got 5 of them here, plus 6 of them here. So altogether I've got 11 of them. Whatever is, in this case, 15ths. Check if it cancels. You've always got to do that in maths. This doesn't, so that would be your final answer. So that's how you add and subtract fractions when the number on the bottom is different. You're looking for the smallest number that appears in both times tables. Now what's going on there? Well, remember I was saying you can't rewrite thirds as fifths or fifths as thirds or anything like that. But the point is that if you could rewrite the thirds and the fifths as some other fraction, then we can do the addition. That's what we're trying to do here. And so you're looking for another fraction that 3 will divide into and 5 will divide into. And the way you check whether or not numbers will divide into is, are they in that times table? If 3 is going to divide into this number on the bottom, it must be in the 3 times table. If 5 is going to divide into this number on the bottom, and we need it to in order for this to work, then it's got to be in the 5 times table. So that's why you're looking for numbers in both times tables, because you've got to make sure that that will divide into that and that the 5 will divide into the 15 as well. Why do we pick the smallest? Well, we're just lazy, basically. We want to make life as easy as possible for ourselves, and you could do it with 30. It would work, yeah? 3 will divide into 30, so will 5. You could put 30s on the bottom here, but if you put 30s on the bottom, then the numbers are bigger and they're just harder to deal with. We just want to make life as easy as possible for ourselves, so we go with the smallest one. And this number here, the smallest number that appears in both times tables, the 15, as I say, sometimes that's called the lowest common denominator or the lowest common multiple. Lowest because it's the smallest, common because it's in both, and then denominator because it's the number on the bottom of the fraction, or if you prefer multiple, because it's a multiple of 3 and it's a multiple of 5. I wouldn't worry too much about the words. Just remember, it's the smallest number in both times tables. So that's why that works. That's why we want to put a 15 on the bottom of here, because we know 3 will go into it, and we know 5 will go into it, and we can then convert these fractions so that they're both a kind of 15th, rather than types of thirds or fifths or something like that. As long as they're the same on the bottom, then we can add them. And we can do the question we need to do. Alright, so let me try a slightly different example, because some of you might be wondering, well, couldn't we have just done 3 times 5 to get the 15? Well, sometimes you can, and sometimes you can't. Let me show you. So we'll have 7/8, and we'll try a subtraction this time, minus 5/12. Now I'm going to show you what would happen here if you did just multiply the numbers on the bottom. Now technically this does work actually, it's just a real pain to do. So 8 times 12 is 96, I think. So we want to rewrite both these fractions so they're something over 96. So the 7/8 is going to be something over 96 minus 5/12 is going to become something over 96. And I know that 8 and 12 will both go into 96 because 8 12s are 96. So 8s into 96 go 12 times. We've times the 8 by 12 to get 96. So we need to times the 7 by 12 as well. And 7 times 12 is 84, I think. You can see why this is not much fun. 12s into 96 are going to go 8 times. So make sure you times the top by 8 as well. Yeah, whatever you times the bottom by, you must times the top by the same thing. So 5 times 8 gives me 40. Now I can do the subtraction. I'm working in 96 here. So I just subtract the tops. 84 minus 40 is going to be 44. The number on the bottom never changes. And then I've just got to check and see if it cancels. Yes, now, well, they're both even, so I know it will cancel. But I really want to find the biggest number that will divide into both here. I'm thinking 4 might go into these. 4 11s will be 44, and I'm pretty sure 4 goes into 96 as well. So if I divide that by 4, that's going to go in 11 times. And well, 4 is going to go into 100, you see. It's going to go 25 times, because 4 times 25 is 100. I know 4 will go into 125 times, and 96 is 4 less than 100. So that's going to go in 24 times. Yes, and you can probably see there, I mean it works, you can do it, the answer is 11/24. But it's not much fun. And adding and subtracting fractions isn't much fun at the best of times. You don't want to make life any harder for yourselves by ending up with really big numbers here that are difficult to cancel down and difficult to multiply and all the rest of it. Let me show you now with the lowest common denominator or lowest common multiple method, the smallest number from both times tables rather than just multiplying them, and you'll see hopefully how much better that is. So we'll start with exactly the same question, and this time we want the smallest number that's in the 8 times table and the 12 times table. So if I write out my 8 times table, 8, 16, 24, etc. And my 12 times table, etc. And we can see already 24 is in both times tables. Now if I carried on here, you'd find 96 is in both times tables as well, but 24 is a lot smaller than 96. So I'm going to rewrite both my fractions over 24. I then just have to work out what 7/8 would be over 24. Well, here I'm timesing the 8 by 3 to get 24, so I've got to times the 7 by 3 as well. Remember, whatever you times the bottom by, you must times the top by the same thing. So 3 7s are 21. Now this fraction, 5/12, I want to rewrite it so it's something over 24. Whatever you times the bottom by, you must times the top by the same thing. So 12 times 2 gives me 24. That means 5 times 2 gives me 10. Now I can do the subtraction because I've got the same numbers on the bottom. 21 minus 10 is 11. Bottom number never changes, remember? The answer is 11/24 because it won't cancel. Wasn't that much easier? So that's why I recommend you go with the smallest number in both times tables. Don't just multiply these numbers, it can be a right pain sometimes. Alright, so that's the traditional method for adding and subtracting fractions, and as I say, that is the one I would recommend in practice. I think it's easier to use if you can get your head around the whole smallest number in both times tables thing. But as I say, if you've always struggled with this, if you never really got it, and even watching this, if you're like, no, it doesn't make any sense, go and try the grid method for adding and subtracting fractions, because you may well prefer that. And it's better that you could do something than nothing at all.